things about Whisper, what you guys are doing here as a host, or someone else from Whisper?
I can do it. Whisper is an anonymous social media platform. So in contrast to Twitter, Facebook, or Snapchat, or any of the other major social media platforms, what people post on Whisper is not tied to their identities. So it's not tied to them in name, and it's certainly not tied to them permanently. And the hope is that it creates a space that people can speak much more authentically and without the filters that we use on the rest of the internet that is so painfully perfect. So, yeah.
And they have an awesome data team, so if you're interested in working for them, then talk to me or somebody else.
For me, Katie.
Or Katie.
All right, so I'd like to. So you guys probably know that I'm very much anti-hype. So there is a huge hype on deep learning. So I'd like to do a survey of really how many people are using deep learning. So how many of you have tried to do something with deep learning? And with the count.
That's pretty big.
Like higher.
Try.
Like one.
That's something.
2, 3, 4, 5, 6, 7, 8, 9, 10. 10. How many have used deep learning for a real project that's running in production? Yeah, 0. Well, we'll see.
Martin has 2.
It's mostly your project.
Alright, so out of those who have been trying it, how many have done something with images? Like 1, 2, 3. Speech. 0. Yeah, 1. Text. 1, 2, 3, 4. Convolutional neural networks. 1, 2, 3, 4. RNN. Recurring. 1, 2, 3. And then I'm going to ask about libraries or tools. And we'll go fast. THU. 1, 2, 3, 6, 7. PyLearn 2. 3. Lausanne. 1. Keras. 3. Cafe. 2. Torch. 3, 4. TensorFlow. 4. MXNet. 2. The 2 of us.
2 set parties.
All right. H2O. 1, 2, 3, 4. Deep learning for J. 0. Anything else? Other libraries, tools, deep learning? Somebody used that I didn't mention? Alright, so thank you so much. Next, I was asking in email if someone has a deep learning case and they want to get a t-shirt and they want to give a lightning talk of 120 seconds right now. Then I have Irina. Anybody else? Lightning talk, so you got 120 seconds.
So I'm Irina. I'm a data science consultant, and I work with a couple different startups. So one of the startups I'm helping build out an outfit recommendation system. So one of the first, so for instance, if you're searching online for an orange print shirt, hopefully we'll recommend a pair of pants and a tie and shoes, and they all won't be orange. So the first step there is to figure out from the title what that category is. So is it a shirt, is it a pair of pants, what is it? And so we used SVM, and that gave 93% accuracy out of sample, and that's currently in production. And we want to increase that accuracy because if I make an outfit recommendation of 2 shirts and a pair of shoes, you're going to know right away that's not really good. So what we're trying to do is see if part of speech tagger will help. And existing taggers, if I use, throw in orange print shirt into NLTK or Stanford, there are all three are going to be nouns. So something as simple as that will just, orange will be a noun, print will be a noun, and the shirt, so that doesn't help. So what I'm working on right now is trying to build a print speech tagger with deep learning. And the goal there is so lessons learned, so I'm using Vienna, but lessons learned are, there's no closed form, so global convergence is not guaranteed. There's lots of parameters, and you need really good training data. And so that's a work in progress.
All right. So you can choose a medium, small, data-driven, or a medium rebel, or large flatlet.
I'll give you the
So how I'm gonna get rid of the other features? So I think Nick is gonna get large. So you can have this, or this is medium, but I think it's like large. Oh, okay. All right. So another lightning talk, someone for sure. All right.
Probably I can just talk here. So as many of you might already know, I'm a big Kaggle competitioner. So I participated so far almost about 100 different international competitions. And the winning solution of those competitions are usually the combinations of XGBoost and one of deep learning algorithm in conjunction with extremely randomized tree or just a factorization machine. So if you have these four algorithms in your ensemble mix, that gives you usually the best performance. And the good thing about deep learning is it complements really well with XGBoost. So those two predictions both are pretty good at maximizing target metrics such as AUC score or log loss score, but combinations of two gives you the best boost when you combine multiple algorithms. So the gain you get by adding XGBoost to deep learning or vice versa gives you the maximum gain you can get out of ensemble approach. So if you are using deep learning only, I recommend you to explore XGBoost. If you are using only XGBoost or GDN, then I recommend you to explore deep learning approach. Yeah.
Yeah, thank you. And by the way, he gave a great talk at the Data Science Meetup a couple of months ago, and you can find it on datascience.la, the slides and also the video recording. So he has a lot of more tips of how to do predictive models that have high predictive accuracy, and including how to win data science competitions. He's crazy. The amount of competitions he's doing. All right, so what t-shirt? You have this for the non-existing anymore company.
Yeah. I'd rather get
Totally?
Yeah.
That's a large.
Yeah. Thank you.
All right, so we'll get rid of this after this, like who can drink more beers or something. All right, so finally we have the talk from Nick, who works at Whisper. He's the machine learning engineer here, and I'm really looking forward to this talk. So I think there is a lot of hype in deep learning. There are very few people using really it and have the knowledge, and I think this one is really the real stuff. So Nick has a BA in math from Harvard, and he's been working in machine learning for quite a while. I actually met him. He was instructor of the data science course at GA, so somehow I got to know
practitioners of machine learning, or even whether that's novice all the way to full-time employed, like expert staff engineer leading a large team, all of us in the beginning had this early moment, like the first thing that you did, you wrote a few lines of Python with NumPy and scikit-learn, and like train your first classifier, even if it was just like a classifier that would determine dogs from cats, right? Simple binary thing. And there's this amazing moment of like, that's so cool that I've made this. It's kind of like when parents see their children talk or like roll over the fur, they're like, look what it learned, right? And I think all of us start in this field from that kind of a place, and then you get into it full time, and it's really nitty gritty, and there's all this. I heard Jeff Hinton refer to it as the dark arts of machine learning. Stuff like knowing how to calibrate a model that's outputting probabilities, or learning the tricks about like batch normalization so that SGD will converge better and all that stuff. And it just gets really gritty, and it's a lot of work, and it can be really frustrating. But hopefully at the end of it, we're all better at our craft, and we're able to zoom out and do more and more awesome things. So on that note, I hope that this talk will be very much in that spirit of starting from the place of wonder at the power that machine learning has, and learning how to do it better so that we can do even more awesome stuff. So this is the world that you as a machine learning practitioner are in right now. Extremely fast and fundamental changes in software and hardware tools. TensorFlow was released roughly out of the blue to people who are outside of Google. And it was really a game changer because it allowed us to have full flexibility in research and development in a Python environment. And before that, there had been a lot of hard choices that you had to make all the time about, do I use something like Torch, which is really awesome, but it's in Lua, or do I use Theano, which is clunkier than I want, or do I use Keras, which is awesome, but it's a little bit more restrictive than a researcher would want. And if you had made all of your production choices up to then in that environment, having TensorFlow would mean that you would have to throw out all your old code and rewrite it all in TensorFlow, and maybe that's kind of frustrating. There's monthly, weekly, even daily advances in the state of the art. You see that if you just check archive on a daily basis, there's always, every week there's a good chance that something came out that is a breakthrough that blows away whatever model you have running in production right now. That's been accelerated by the fusion between academia and industry that we've seen recently. Very high-profile people like Jan LeCun going to Facebook, or Jeff Hinton being bought out by Google, or Peter Norvig is like the research director at Google, and the list goes on. People who are less high-profile but equally important in the world of machine learning. When you put those people in places where they have a lot of money behind them, it accelerates the development of the field in really cool ways. There's also, as a practical matter, dealing with web data or real-time data or machine learning in production environments rather than strictly research environments is covariate shifts. So the data that you train on, the future does not look exactly like the past, and the data that you train on is not 100% representative of the data that your production system is going to have to deal with in the future. And so you have to do things that will deal with that will learn over time. So the challenges are very high. If you compare this to what things were like in the 1990s, when it was really a bunch of researchers sitting around like writing about support vector machines, and then like kernel classifiers were just state of the art for like 4 years straight, and nothing really changed that. Change is happening a lot more quickly now. And of course, there's also product changes for any company that you want to work on, or any company that you work in. So with that background, I want to talk about something that I've worked on pretty extensively at Whisper for, I guess, almost a year and a half, which is content moderation. So there's this quote that some people like at Whisper which is man is least himself when he talks in his own person, give a man a mask and he will tell you the truth. It's from Oscar Wilde. It's somewhat of a thesis that motivates the existence of Whisper at all. The point is on Whisper people have the freedom to say anything. You know, this is stuff that you just wouldn't tweet, you wouldn't put on your Facebook. Maybe it's even stuff that you wouldn't tell most of your friends. Like, I'm depressed, but I don't have anything to be depressed about. Or this guy just argued with a 10-year-old about Lion King versus Frozen. It's embarrassing, right? And the flip side of this is that there's freedom to say anything, right? So you can't do that on Whisper, you can't sell drugs. No one wants you to be their daddy, bro. And this is just like mean, and that's just a terrible thing to put out into the world, right? So you want to allow people freedom, but you can't just back off and let it be an open field, because then you get nasty, brutish, and short. And that's the motivation for moderation, right? It forces this continuous existential discussion about what sort of platform do we want to build here, which is cool. More concretely, you have to say, what are the rules? What do we allow or not allow? At Whisper, that's taken the form of we don't allow stuff that's extremely lascivious, and we don't allow selling of drugs. We don't allow threats of violence. We take that stuff very seriously, and even work with the police on it. And all of these things, and there's like a 23-page document somewhere that lawyers have written out about what the rules really are. And as soon as you've got those guidelines, how do you enforce them? You need a lot of engineers to build a lot of stuff just to allow content people to enforce them. And even once you've done that, how do you do that as scale goes up? So this is a pretty good place for automation, as you might see, and the endpoint of our story is where we are today. We built a deep learning system that moderates all the whispers created by our more than 30 million monthly active users, and it does this in real time. It makes a simple binary decision. So regardless of what the reason for something, say, being deleted is, it doesn't really matter. It just says that it's bad or it's good. In the cases that it's not confident enough to make its decision, it will refer it to human moderators who are really awesome. It uses different models for different environments. I'll talk about what that means later. It's 100% agnostic as to the language of input, so it doesn't matter if you're speaking English or Spanish or Arabic or Malayalam or whatever. It just sees an incoming stream of bytes. And it learns and updates continuously. This is a pretty powerful system, and it's a pretty big part of Whisper's competitive advantage in staying afloat where other anonymous apps have gone under because the service just became too vicious and gross. So, with that as the endpoint, let's go back to the starting point. In 2012, in the very early days of Whisper, the moderation approach was humans just review every single post. So, I think Kurnow was the first. Was he the one who was first? Yeah. Anyway, humans review every. Obviously, that doesn't scale very well. So. You can use a rule-based classifier to make it sound like it's doing machine learning, but it's just keywords, right? You say there's some, if you like the word dick is not allowed on, so you just if there's a regex match for that word, then it just goes to the human queue, and if it doesn't match that, then it's fine, I guess, right? You can immediately see the limitations of this. For one thing, it's a really inexact method. Words can be used in lots of different circumstances, and there's words like the word fuck, which can be totally fine as far as our guidelines in some contexts and totally not fine in other contexts. It's not fine-grained at all. The other thing is that some words are sort of, we're not really sure. Some words are really terrible, you always want to delete them. There's no accounting for this in this simple system. So we moved to a multi-tiered keyword system where some words are really awful and we don't ever want them on there at all, so delete them immediately. Some are, we're not really sure, so send it to moderation, and others, we'll just let it go live. And for the first while of Whisper's existence, this was how it worked. The good part is that it allowed Whisper to grow. The bad part is that Whisper grew, and so these methods does not scale, and so we had to hire lots of contractors. It's really expensive. And then I joined. So the big positive here was that at the end of a year and a half or so, 2 years of this kind of a system, we had millions and millions of labeled data points, which is great for machine learning. So I actually remember our director of trust and safety took a trip and went to go see a bunch of the moderators. And she went to the facility, and when she came back from the trip, she was like white in the face, like she just looked like she had seen a ghost. Because our system was so at the breaking point, Whisper was growing too fast, and we couldn't get enough people to keep up with the moderation needs. So I said, I bet I can do something quick and dirty that might help a little bit with that. And that became version 1 of this machine learning based content moderation system. It's pretty scalable. As a side note, why is it called the arbiter? I get that question a lot. The answer is because it's an arbiter. So the first version of this was a linear model, logistic regression on bag of words features. There's a little bit of fancy feature engineering, but not really, like bags of words and stacked with bags of chars and grams of chars and that kind of stuff. But pretty basic stuff. It was scikit-learn. It did take 1 day to prototype, run through a bunch of different methods, do hyperparameter search, and then validate a final model. It took something like a week to make a full production system. And 25% of that moderation load was immediately reduced. And that's with very, very stringent constraints for false positives and false negatives, so that the machine is guaranteed to make fewer errors than humans. And even with those false positive, false negative restrictions, it still took 25% of the load immediately off. So that's a pretty big win for a day's work. And it also stops a lot of people at Whisper from panicking about what was going to happen to the service. But as any good algorithms person, any good software engineer is always asking themselves, can we do better? Or good work leads to more work. And the answer, of course, is yes. I remember after we deployed this, this was sometime over a year ago, and I had to leave pretty shortly after to go to several weddings on the East Coast, and as I was leaving, I was like, okay, this big deploy system is like working pretty, but like we got to do better. Oh, RNNs. I bet RNNs would be really awesome at solving this problem because they're good for NLP problems. So I was saying, oh, as soon as I am done with these weddings and I get back, I'm just going to start hacking away at the RNNs. It's going to be awesome. It's going to blow everything out of the water. And so when I came back like a week later on Monday, I remember I walked into our data science cave, and Martin was sitting here. He's like, Nick, me and Mark have been working on RNNs. We think they're really awesome. It'd be really awesome for the arbiter, wouldn't it? Yes, but he's my thunder. But we did that. So V2 of this was a 1-layer LSTM on words, and that's still deep learning, even though it's 1 layer. Does anyone want to explain why that's still deep learning, even though it's 1 layer? Exactly, because RNNs are equivalent to very deep unrolled. When you unroll an RNN, it's equivalent to a very deep neural network, feed-forward neural network. We pre-train using Word2Vec on, of course, our own data, not like, you can find Google's pre-trained binaries of their own word. We don't want that because the way that users talk on Whisper is very, very different from the way that users talk on Wikipedia or on most of the data that Google uses. So it's Word2Vec algorithm but trained on our own data. You get fixed vocabulary and word vectors. You use a lookup table and you feed a sequence of word vectors into an LSTM, pull the outputs in whatever way you choose, feed it into a classifier, and then you're done. IP theft. That was an even bigger one. That reduced the load by 34%. And it was kind of it was really the starting point of what's become the longer journey of this, which is like doubling down on deep learning and trying to use deep learning to make better and better more and more elegant and more universal models for dealing with this content moderation problem. The big cons of this are, it's a fixed vocabulary. So when you pre-train on words so that you're done, you can't augment it later. Another big problem is that there's several problems that fall out of that fact. One is that covariate shift problem. Users change the way they talk over time. And in particular, if users are really smart, especially the younger, like high school users, they'll figure out that if the phrase like "kill yourself" is always going to be deleted, then they abbreviate it to KYS, right? And that doesn't really get cached. Or there's stuff like they'll use, do the classic hacker thing of substituting numbers for letters, and so then that's not the vocabulary, so it's UNC. So the classifier doesn't really pick up on it, right? The other thing is that the long tail isn't really captured in that vocabulary. So languages other than English, Spanish, and maybe a few others are totally unknowns. So you can't deal with them. So if we launch in, I don't know, where's somewhere that would have a language that is not commonly used?
Iceland.
Malaysia? Okay, Malaysia or Iceland, either one. I like Iceland because there's not very many people live there. If you launched in Iceland, then suddenly Iceland is just, it's a free-for-all, right? Anyone can, there's no moderation happening there. So we want to fix that. The other real con to this was that it was written in THU, which I'm not very partial to. THU, especially at that time, was clunkier than a lot of other libraries. It's just difficult to understand, it's not that readable, kind of difficult to deal with, so not ideal. Oh, and by the way, as a review, this is, for those of you who don't remember, this is what an LSTM is. There's an input gate, a forget gate, and an output gate, and these are all sigmoid activated, and then the output is usually tanh activated. So it's a very sophisticated machine, it's a very sophisticated machine that doesn't have that many moving parts really, or in machine learning terminology, doesn't actually have that many parameters. But it has the capacity to learn really long-term dependencies because it can store things that it thinks it needs to remember for later and then forget them. So if you have a very long sentence, it can remember that, in this case, like some word that means that it probably should be deleted happened a long time ago, but then that got negated, so we throw that up. And there's other words, so remember that, and then we throw it. And so there's very long-range dependencies that's capable of learning, and it makes it much better suited to sequential data, in particular language, which is sequential and has really long-range dependencies. Been very successful. As an aside here, you might ask why RNNs, and to some extent what I just talked about is a big part of that, but there's been a lot of papers and a lot of graduate students working and a lot of kind of buzz about convolutional neural networks applied to text. We have tried this many times. They just never work as good in practice as RNNs. I think that's intuitive. Does anyone want to talk about why that might be intuitive? No one wants to talk about that. Okay. Well, I'm going to talk about it. The reason is that you usually use a fixed width convolution, and so you've kind of taken a step backwards to like an n-grams of chars regime, where you're saying, oh, these 4 slots, they're always together, and we only look at those. And while you can make a convolutional net that's really high capacity, it'd be a huge net, you're ultimately dealing with a feature input regime that's not really built for language. I blame Jan LeCun for this because he's made his entire career off of convolutional neural nets back in the 80s, and now he's at Facebook and he's doing tons of awesome stuff, but he wants convolutional neural nets to solve every single problem. And he usually fiddles with things. He's a master of fiddling with stuff until he gets it just right. So he'll do that, he'll publish a paper, and it's like, oh, CNNs are just as good as RNNs, but they're not though. But there's lots of good stuff. The other downside is that, so it's true that convolutional neural nets are much more feasible to parallelize than RNNs, but that's a lot of work, and why do it if it's not even as good? They're much, much bigger models, so you might even have to break them up over multiple GPUs just because they have so many parameters. But the point being, they're just not as good and they're much bigger, so we stay away from them for the most part.
Isn't bigger better? Big data?
No, more data is not always, you're totally trolling here. More is not always better. For example, like more data, if you gave me a terabyte, I would just sample a gigabyte of it down and use that. The terabyte takes up a lot of memory, and then I have to write a lot of really good code that will chunk it from disk, but do that asynchronously so that it's not burning training time with disk I/O and all this stuff. And that'd be fun for me, but it would also take me like a day or two that I should be spending doing more important things. So more is not always better. Like more data certainly is not always better. More model parameters, definitely not always better. You know, basic machine learning theory, you pick the model that you have enough data to justify, not one that you think fits the data the best. But even at that, model structure starts to really matter, especially with deep learning, with really high complexity data like language. So if an LSTM captures the structure of language much better, it can do that much better with fewer parameters than a convolutional neural net. It's just not the right tool for the job. More knowledge is better.
I hope everyone wants to listen.
Anyway, so again, can we do better? Always more work to do. So we had the Arbiter version 2.1, which was an ensemble of one-layer LSTM models, just like I just described. Some were written in THU, some were written in Torch, and they were combined in production using microservices that communicate via HTTP. By microservices, I just mean a service running on a server somewhere that communicates with other things via HTTP or FTP or whatever protocol. It's notable that at the time that I designed the system, there was no FB Python. So the important point was that there was no really good, clean, simple, reliable way to communicate between Python and Lua, like an interpreter or a foreign language interface or anything. Like nothing really worked. Now there totally is, and this problem is much easier. But this was a learning experience for me as well, because I was super proud of how nifty this whole setup was. I was, oh, this is so great. We're gonna all the engineers in our group can use whatever tools they want to. People can use THU, or they can use Cafe if they want to, and I can use Torch because I really like Torch. And then all we have to do is have a standardized way of communicating with each other via HTTP, and we have much more flexibility in our group, and it's just going to be wonderful. No, it was terrible. It was horrible. It was awful. We got a 30% load reduction, so up from 34%. So that's good, just on the basis of the ensemble. But what ended up happening was we had to run one server in Python, which we have been doing forever, and we had to run another server in Lua that it also had to be able to load Torch, which is a large external package. And I remember I sat for 3 days with one of our DevOps engineers, Perry, in the data cave, and it's he's a super serene guy, but it's the most frustrating I've ever seen in his entire life, because Nginx would just spawn these random processes, and it was terrible. The point being, keep things simple. Just really keep it simple. Be very strongly biased towards simplicity in your production systems. Use the tools that you've always been using. Don't make new nifty stuff because it will cost you much more than it gets you. And at the end of it, I ripped the entire thing out, deleted all the code, and rewrote it all in THU and Keras. So that was fun for me. Okay, the same question that we always have. Can we do better, or can we do more? Oh, good little hot here, excuse me. So in addition to all of these research and development or technical concerns, this project does not exist in a vacuum. It exists within a company called Whisper. And there were product expansions happening during all of this time that made more demands on the content moderation system. So one is, there's a big push for internationalization. We hired a director of internationalization, launched in Spanish-speaking markets, had an eye towards lots of other markets. And if you remember, the fixed vocabulary system really doesn't allow a good way to deal with that. You just have to constantly retrain your vocabulary or something. We launched a schools product, which was awesome, hyper successful, but we also had much more stringent requirements for what we allow and don't allow in schools than in other places. It was very important to the company to keep schools a really, really positive, totally free of any negativity or any bullying. Bullying was a big concern. Obviously, any threats of violence, like I'm going to shoot up a school, it's something that we take very, very, very seriously. And so the rules effectively changed for that product domain. More users, more problems. You got bigger scale. They're creating more whispers. It's like putting more demand on the servers. It's all those problems. We wanted to handle replies, so users can create whispers. They can also reply to other people's whispers. And that's a different kind of problem, right? Because there's an original, there's a context, and there's it's like a conversational model instead of a single short text. There's also the clever users problem, that users are constantly finding what your model is doing. They know what's going to get deleted, and they'll find ways around it because they're smart. And there's tons and tons of other concerns. So that led to the Arbiter v3. And this is the current state of the art around here. And this is a system that I personally am extremely proud of, and it's taken a lot of blood, sweat, and tears and lower back pain. It's composed of deep LSTMs, which are 3 layers deep. So we're like deep squared learning. Anyway, it's 3 layers deep LSTMs, and it works only on chars. So it's totally natural language agnostic. All it sees is an incoming stream of bytes. And what happens when you stack LSTMs like this, depending on the task, 2 or 3 layers usually is the best number to use. It captures really, really long-range dependencies. So you can feed it like really, really long sequences of chars, and it will still learn word representations out of that. That also allows you more flexibility. One, because users are typing on iPhones or Android phones, they don't spell very well, or they change their spelling, or like one random person decides to put like 14 Y's at the end of happy birthday, and like if you use a fixed vocabulary, it's going to mess up your model. With just a stream of bytes model, it doesn't matter. You throw whatever you want at this thing, it's always going to be fine. There's only 4 different models here. There's a top level, which is global for all of Whisper. There's a replies model, global for all of Whisper. There's top level for high schools, which only works on high schools, which have more stringent rules. And there's high school replies. We also set up a system with the human content moderators we have in-house here, that they will every day go through and find the few mistakes that the machine is making, label them as such, and so we have effectively online updates from that, where it's a constant feedback system. One of the big wins for that is not just capturing things that weren't caught in training. It's dealing with covariate shift, that thing that we're constantly talking about, where when the high school users start typing KYS instead of kill yourself, it only takes us 12 hours or maybe 1 day to catch up with that and start moderating that term as well. So the arms race, like, we're able to keep up now. As far as load reduction, it's nearly 70%, which, thinking back to over a year ago, I remember we had a staff meeting, I was talking about this project, and I said, my moonshot goal was, we're going to get 50% load reduction. And when I said, I was like, okay, cool, so that'll be in like 4 years. That might never, because that's ridiculous. Lo and behold, 70% load reduction. That's pretty cool. Also, for very large model capacity, I mean that in the sense of machine learning theory, there's not that many parameters, and this thing is pretty quick to train. It converges in a matter of hours. The big con for this so far, which is something that I'm currently working on, is it's not obvious how you do SGD on daily online updates, especially since most of our best optimization methods, it's like Adagrad or Atom or even Momentum, where you have to have like a running record of what your gradients were. That I'm confident will work itself out. This also was written entirely in TensorFlow, which was, as I said before, it's a big deal. You're finally able to do all the R&D in Python, and then with very little modification, plug that straight into production. That's a big deal for the sense of freedom and flexibility that we have. It's also a big deal for prototyping. Prototyping is much, much faster now. And just as a sense walking around, that any idea that you might have, it will never be the case that I'll be able to demo this in Torch or something, but then it'll be like the Netflix prize where it was just too difficult to get into production. That will never happen. If you can make a model, you can put it in production. We also purchased and built our own hardware in-house, which Tony was very helpful with. Tony's a DevOps guy, he's back there. We got 4 NVIDIA Titan X GPUs. This thing is a beast. It sits upstairs. It takes 2 people to carry it. It has like 36 terabytes of storage. It's really awesome, but we just have it sitting next to our desks and makes things really, really fast. It also allows us to use state-of-the-art open source software. So certain packages in Torch and I think in TensorFlow, I'm not sure, but definitely in Torch, there are some packages that require a CUDA compute capability that's greater than what AWS has. So there were models that we wanted to run that we just couldn't do it because AWS has these really old, busted GPUs. But this represents a factor of like 14 on speed up in your training time, so it's a big deal. Highly recommend it. Another thing is I used the bootstrap loss, which is this thing that's from a Google paper to deal with noisy data. What it does is it takes cross entropy and it says, okay, we're going to treat this like there's an 80% chance that the label that you gave us was really the right label, but there's a 20% chance that what the model predicted was more accurate, that your label was wrong. And Google developed this to deal, obviously, with noisy data in the web domain. This performed significantly better than standard cross-entropy loss. Now, a follow-up question would be, how in the world did you know that it was better if all of your labels were like wrong? And the answer is that you put it in production, you put it in, and you test it on a small subset of whispers. We tested on like 1,000, I think 2,000 whispers, and had the content moderators go through and pick everything. And sure enough, the false positive and false negative rates were like 1/4 of what I had expected them to be. So that was a big win too. As a matter of software design, I rewrote the entire thing as an object-oriented library. It uses these modular building blocks of preprocessors for your text, some kind of vectorization scheme, and that could be sequences, it could be bag rewards features, it could be n-grams of charge, just whatever it is that puts it into a vector space. And then the machine learning model, the LSTM, or the logistic regression, or whatever it might be. That, I have been surprised at what a huge win that has been for me personally. Obviously, all of the good software design standard wins that you would get, like testing is easier and all this stuff. But the big thing is that prototyping is way, way faster because it just turns out that you end up as a researcher getting one thing right and then almost never finding something better than that. So if you can just switch out one little block, it makes your prototyping much, much faster. It also allows us to reuse these tools in other machine learning projects. I talked about the replies problem as well. So on Whisper, people can post replies. So like this person said, I passed my permit test. I guess the driving permit. And this person said, congrats. And they had some party emojis. fun. So this is a different kind of problem from the top level, right? Because there's this context, right? But then what you actually make a approve delete decision on is this thing right here. So it feels like this is fundamentally different. It's more difficult, right? We struggled with this for a pretty long time, but it turns out it's not actually that different. What we got the best results from was don't consider the original at all. Only look at the reply. I think it's possible that future models like attentional models or more stuff that maybe has yet to come out will be able to consider that context better, but for now, and it wasn't even like close, it was like only looking at the reply destroyed the mixed model by like 20% or something. Wow. So I think there's a good lesson in here too, which is that smart models are easily confused. And a lot of the dark arts, as I called it, of machine learning is like getting this model that's very high capacity to learn in an optimization algorithm like SGD that's pretty dumb. Like SGD gets in these bad sap point, all this, right? You just don't confuse the model. So for some takeaway lessons, things that hopefully are generalizable from my experience here at Whisper that you guys might take whatever you do. One is expect covariate shift. Expect the distribution of your data to change over time and build infrastructure for continuous learning. I can't think of any web domain where you wouldn't be dealing with changing distributions over time. Certainly if it's user-generated content. Like users, like that's what trends mean, is that things come and go. Right? So just expect things to change and build infrastructure to deal with that. You should also expect noise that you cannot clean out of the data. That was one of the biggest problems early on that I had in this problem, is that we had hundreds of millions of labeled data points. But occasionally they were wrong because humans make errors, right? All models make errors, even if that model is a human. So you have to use methods that are noise robust, and that can be everything from using linear models because they're low capacity but also robust to noise, to things like the bootstrap loss, which I found to be very effective. But the overarching point is like you're not in a research regime anymore, so your data is going to be dirty in a way that you just can't clean it out. Thirdly, expect to rewrite, and don't be freaked out by that. You should expect new breakthroughs just as soon as you coded up the old breakthrough and put it into production. Like even on R&D, done is better than perfect. That was an important point for me to internalize here. You should also expect software tools and systems. This is even the biggest one, is expect software tools and systems to change all the time. As I said, when TensorFlow came out, we weren't expecting it to come out, and it totally rendered obsolete all of the code that I'd written for months ahead of time. That's okay. Your job is to handle today and tomorrow, right? Know that whatever comes in the future, it's only going to be a step up, right? Obviously, you're only going to make a big change like that if it's an improvement. So it's a good thing, even if it's a lot of work. Also, rewrites are an opportunity to write better code. I saw once some software engineering blog somewhere said, like, write everything twice. And I think in this domain, it's like, just expect to always rewrite it like every so often. Make greedy decisions. I mean that in the sense of greedy algorithm. Just do what's locally optimal and be okay throwing it out 2 weeks from now. There's a small topic. Make things easier for the algorithm, as we talked about. Clean your data as much as we can, but use good optimization algorithms. And most importantly, as to people, hire people who love this stuff. There's no excuse not to. There's just too many people out there who really do approach machine learning with childlike wonderment. And at Whisper, I think if we've had every success that we've had in the applied research, the data science and machine learning group, it's been because we put like 5 or 6 people together who really, really love this stuff. So everyone's always like checking archives to keep up with the latest papers, or like watching videos, or people want to go to talks, or like people are constantly educating themselves and thinking about it on like Saturday in the shower, whatever, right? And that, no, I mean, I think the productivity of a group like that grows, 2 to the n, where n is the number of people who really love this stuff. And there's definitely been critical points at which Martin or Mark or Lush or anyone else sat down with me and said, oh, I bet you change this one thing and this model will be way better, or like, help me fix a bug, or they'll give me some idea for a way to tweak the model that will make it much, much better. So focus on that. And as a follow-up, take care of yourself and your team. Let people be free and run with stuff. And when you unleash a team of good people, that's where you get really, really good results. There we go. So finally, go forth and do awesome. The promise of machine learning was never just that a bunch of researchers at Google Research and Facebook Research and the faculties of Stanford, MIT, and University of Toronto would write papers to each other and break thresholds on Sci-Far 10 and MNIST and entry making, all that stuff. Like, that's part of it, but a bigger part of it is people like you taking all of these amazing tools and deploying them in new and original ways as well. Just as a final, by the way here, so I've talked about content moderation, which is mostly my project. Other ways that we've used deep learning at Whisper, we've had huge successes across the board. Learning to rank our image suggest algorithm. They're developing something right now that will do image retrieval given text. Feed generation, retrieval of related whispers, or users who are similar to other users. The recommendation engine, and there's a lot more applications. There's a lot of work to be done, and we are hiring. So talk to me or talk to Katie if you really love machine learning. That's all I got.
Questions?
So I have a question.
Yes.
So you have this character-based approach, which is really nice because it's
Yeah.
language agnostic.
Yep.
But then you go and have this high school there.
Yep.
What does that give you? And don't you have to isn't that like a US idea and now it's fixed in English?
High schools?
Yeah.
Oh, so high schools is a separate product. So there's 4 models. There's top level and replies, which is for most of Whisper. And then there's separate high school models, like models in the sense of trained separately on separate data, have their own parameters. It's like a different model. And high schools right now, I believe are only US, so it's only English. Theoretically, it should be learning anyhow over
Right,
time,
right.
regardless of language. Like there's a lot of Spanish speakers who are in high school too.
So you still feel you need it.
The high school model, it does because there's a lot of data points that in the general case, like the global case for Whisper, would be approved, that in high schools they would definitely be needed.
All right, I have a... Okay,
Yes.
go there.
So you can still use Keras with the THU, TensorFlow as a backend.
You're
What
right.
made you decide to move away from Keras? What was the major factor to rewrite code with TensorFlow?
Good question. So right before TensorFlow came out, everything was in Keras. There was a small gap of time where TensorFlow 0.7 was out, but Keras hadn't fully moved. They were trying, they were working amazingly quickly to do so, but they hadn't fully moved, and then even after they did, there were some bugs, some lingering bugs, and I really just didn't want to deal with that. I was at a point where I wanted if I'm going to be spending so much time with this system, if I'm going to be effectively writing my own library anyway, I would rather have all the bugs just be mine, be able to change all the code by myself and not have to fork something and do all this stuff. The other thing was, as great as Keras is, and I think it done a marvelous job, especially for an open source tool it's not even like sponsored by a big company, it's just, Francois Cholet made this thing and it just blew up. I think they've done an amazing job for making it a very good amount of modular and lightweight, but still flexible, which is a really difficult trade-off to get right in machine learning. But even at that, I wanted 100% flexibility to do anything, things we don't even know about yet. And so if some model comes out and it's totally great, and I want to see, even like it's not even validated, I just want to see, hey, I wonder how like model XYZ performs on Whisper's text data. I can do that. I don't have to wait on Keras to put out the XYZ class.
So you have 4 GPUs. Are you using them in distributed way, or are you just doing like research kind of thing, the different models on different GPUs?
So parallelizing over multiple GPUs, it's super awesome, and it looks really awesome, and people have gotten really great and admirable results. It turns out that if you don't have a library that does it for you, it's kind of tough. Yeah. It's kind of a lot of work. So with these models, there's for what?
For RNN.
Yeah, it's way hard for RNNs. It's actually not even obvious that you can.
But do you need
meaningfully do
it?
So that's the point, is that these models are small enough to fit on one GPU. It's a better use of time to train 4 of them in parallel. Even like different architectures, everything.
Yeah.
You get a bigger speed up than if you really did a distributed kind of thing.
And the other thing is, how do you deploy in production?
Good question.
It's gonna be like a feed forward is very easy. It's very hard. You don't need the GPU there. You just have the scoring function that's very fast. I'm not sure about the RNNs or.
So that's,
how do you deploy in?
Currently, they are deployed just on CPU, and we have enough servers, enough workers, and it's just fast enough that it's within reasonable limits for response time. That'll be an engineering challenge that we'll tackle as we need to. If we need to introduce queuing, or if we need to get a GPU system and batch things, there's the way forward is pretty clear. But for right now, we are running just fine on CPUs.
Can you share this latency numbers or anything like that?
It's like,
for
100 milliseconds for response.
For 1 whisper.
Yeah, 100 to 150.
Yeah, because you have to do sequentially.
Yeah.
It cannot.
And it's charged, so it's long.
Right.
When you say charged, you're talking like UTF-8 characters?
Yeah.
Is that what you're talking about?
So that's
bytes.
Right. So what I do is, there's a lot of different ways to do it, but one easy way is in Python, you just do ORP. Yeah. And UTF-8 and all that stuff, but yeah.
All right.
It's pretty cool because it's
Can you say
totally
what
standard.
ORD does? I saw that today. What is that? Does that convert it to UTF-8?
Yeah.
Oh, really? Okay.
Well, it'll convert to ASCII or UTF-8. So you have to to make sure that you don't get an ORD of 12,000 or whatever. You have to encode it ahead of time, but yeah, it'll convert it to its
Just me.
I was curious about your difficulty with the top level of replies problem, and it would seem that if you've already tossed a top level, then all the replies that go with it obviously go too. So I was wondering if you were training the full set of toss top, or were you doing the slightly harder problem of things that where the top level was allowed, but the replies were...
It's that, yeah. It was one of the most, biggest ROI, but most painful parts is writing the SQL queries that go into Presto and retrieve all this data. And that was one of them, was getting only stuff where the top level has not been deleted, but the reply was deleted, but it was a reply to a top level, not to another reply, and all this stuff.
It seems like that's a harder problem than
Yeah.
trying to learn the whole replies.
Yeah.
Independent of that.
I'm just question about the covariance, which seems like a really good feature that you built in, and then you have people kind of looking at things that were really misclassified. You feed that. Were you doing that internationally or just in the international?
All the platforms.
Gotcha. And then is there user reporting in it too? I don't think you talked about that.
Is there what?
Is there user reporting? Is there an actual instance where users are reporting posts and then that's going back into the model?
That does happen on the service. It's not part of the machine learning infrastructure. So basically, the moderators serve as our So they're the ones who say, okay, this was mislabeled, this was not mislabeled, that stuff.
In terms of different training models for posts versus replies,
Yeah.
you mentioned that most of the time replies correlate to posts. Have you seen differences between like the way people reply is significantly different than the way people posts or something?
So you mean, is there a meaningful difference in the language people use if they only reply versus if they never post the top level?
Or posts versus its replies?
Oh, I see. Yeah, the language is very different. And that's something that for a long time made the problem so hard, is that a lot of our replies are like, yes, no, awesome.
More questions?
Not referring to like general modeling and stuff, I know it's more math, but logistically for parts of it, is there any testing frameworks or stuff that makes it easier? Like, there's a lot of probabilities and stuff, so.
Yeah, oh man, great question. Doing like testing on machine learning frameworks is just really, really hard. Personally, what I've found to be effective and perfectly adequate is just having extremized test cases. So like I have this text that's just horrible, like must always be deleted, right? And if that does not get deleted, then the test failed. And like hello world should always be approved, so if that's not approved, there's a problem.
So your study model is like still continuous update, so right
Yeah.
now every day there are still manual label data feeding to this model.
Yeah.
All right,
Do you feel pressure to update your GPUs? Like, NVIDIA just came out with new stuff.
Oh, I think you mean the newest NVIDIA stuff? My opinion, I'm on camera, I don't care. My opinion is that the Titan X is incredible, and I hate the word future-proof, but they're future-proof for a good while, and the stuff that NVIDIA most recently released is really just marketing BS that they've realized they have a huge opportunity to make a lot of money off of people who aren't that knowledgeable, are in large companies, have a lot of buying power, need to do this deep learning GPU stuff, and so they're going to spend a lot of money to get Blaze to this thing, but it's at best marginally better than the Titan X, in my opinion.
All right, it was an awesome talk. Thank you. I guess we still can hang out here for like a few minutes. So feel free to talk to the whisper guy.
Accuracy, because if I make an outfit recommendation of 2 shirts and a pair of shoes, you're going to know right away that's not really good. So what we're trying to do is see if part of speech tagger will help. And existing taggers, if I use, throw in orange print shirt into NLTK or Stanford, all 3 are going to be nouns. So something as simple as that will just, orange will be a noun, print will be a noun, and the shirt, so that doesn't help. So what I'm working on right now is trying to build a print speech tagger with deep learning. And the goal there is lessons learned, so I'm using Vienna, but lessons learned are, there's no closed form, so global convergence is not guaranteed. There's lots of parameters, and you need really good training data. And so that's a work in progress.
All right. So you can choose a medium, small, data-driven, or a medium rebel, or large flatlet. So how I'm gonna get rid of the other features? Alright, welcome to the Data Science Meetup in LA. So, let's thank Whisper for hosting and for feeding us. Nick, you want to say a few things about Whisper, what you guys are doing here as a host, or someone else from Whisper?
I can do it. Whisper is an anonymous social media platform. So, in contrast to Twitter, Facebook, or Snapchat, or any of the other major social media platforms, what people post on Whisper is not tied to their identities. So it's not tied to the name
me, for somebody else?
For me, Katie.
For
Hi.
All right, so I'd like to. So you guys probably know that I'm very much anti-hype. So there is a huge hype on deep learning. So I'd like to do a survey of really how many people are using deep learning. So how many of you have tried to do something with deep learning and with the account?
That's pretty big.
Like higher.
Try.
Like one,
That's something.
2, 3, 4, 5, 6, 7, 8, 9, 10. 10. How many have used deep learning for a real project that's running in production? Yeah, 0. Well, we'll see.
Martin has two.
It's mostly your project.
Alright, so out of those who have been trying it, how many have done something with images? Like 1, 2, 3. Speech. Probably 0. Yeah, 1. Text. 1, 2, 3, 4. Convolutional neural networks. 1, 2, 3, 4. RNN. Recurring. 1, 2, 3. And then I'm going to ask about libraries or tools. And we'll go fast. Piano. 1, 2, 3, 6, 7. PyLearn 2. 3. Lausanne. 1. Keras. 3. Cafe. 2. Torch. 3, 4. TensorFlow. 4. MXNet. 2. The two of us.
2 set or
Alright, H2O. 1, 2, 3, 4. Deep learning for J. 0. Anything else? Other libraries, tools, deep learning? Somebody used that I didn't mention? Alright, so thank you so much. Next, I was asking in email if someone has a deep learning case and they want to get a t-shirt and they want to give a lightning talk of 120 seconds right now. Then I have Irina. Anybody else? Lightning talk? So you got 120 seconds.
So I'm Irina. I'm a data science consultant, and I work with a couple different startups. So one of the startups I'm helping build out an outfit recommendation system. So one of the first, so for instance, if you're searching online for an orange print shirt, hopefully we'll recommend a pair of pants and a tie and shoes, and they all won't be orange. So the first step there is to figure out from the title what that category is. So is it a shirt? Is it a pair of pants? What is it? And so we used SVM, and that gave 93% accuracy out of sample, and that's currently in production. And we want to increase that